More algebraic fractions. This time we're going to look at how we add and subtract algebraic fractions and how we work with them when they are in an equation as well. So again, the same rules that apply with ordinary fractions apply with algebraic fractions. So you cannot add them together until the bottoms are the same. Now, if you think about what we typically do to find the new bottom, is we multiply the old bottoms together to get that new one. So that's what we're going to do here. So the new bottoms are going to be x plus 2, x minus 5, and same for this one. So that's our bottoms. And eventually we're going to add the top part. So now we've got to work out what goes on top. So just remember, what we do to the bottom, we do to the top. So we had x plus 2, we multiplied it by x minus 5, so we multiply the top by x minus 5. One lot of x minus 5 is x minus 5. Same over here, so we started with x minus 5, we've multiplied it by x plus 2, so we need to do the same to the top. So we've got two lots of x plus 2. So that's 2 brackets x plus 2, which if you expanded out would give you 2x plus 4 on the top there. Okay, so the final thing that we've got to do is add together our tops. So I'll do that without doing the bottoms here. So we've got x minus 5 plus 2x plus 4. So we need to tidy that up, simplify it. So we've got 3x, and minus 5 plus 4 gives us minus 1. So our final answer will look like this. It's going to be 3x minus 1 on the top, x plus 2 brackets, x minus 5 in brackets on the bottom. So that is the answer. We'll do another one. This one's a takeaway one. Okay, same thing. We've got to get the bottoms the same, and we get the bottoms by multiplying the old ones. So we've got x plus 2, x minus 1, x plus 2, x minus 1. That's our two bottoms, and this time we're going to be taking away the top. So x plus 2 we multiplied by x minus 1, so we need 4 lots of x minus 1, okay, which equals 4x minus 4. Okay, on this side we started with x minus 1 and we multiplied by x plus 2, so we're going to need 5 lots of x plus 2. So that means we're going to have 5x plus 10. Now this is where we need to be careful with doing the takeaway on the top. So we've got 4x minus 4 minus, and I'm going to put this in brackets to really make this stand out, minus 5x plus 10, because we've got to take away all of this, not just the 5x at the beginning. So what we've really got is 4x minus 4 minus 5x minus 10. It's that second bit that people miss out sometimes. So 4x minus 5x is minus x. Minus 4 minus 10 is minus 14. So that's what's on top. And on bottom is that x plus 2 in brackets x minus 1. Now, if you think there's any vague possibility of factorising the top so that it will cancel with something on the bottom, then give it a go. But normally that is the end of the question. So we're going to look at a couple more examples. Okay. Now, this is a difference of 2 squares. And that would mean that that would become x minus 3 x plus 3 if we factorised it. Now, why am I pointing that out? Because this is a situation where we don't need to change both of the bottoms. Okay, because we can turn this one into this bottom and just leave this one alone. So the other bottom is going to also be x minus 3, x plus 3, and we're adding the tops this time. Now, what if we multiplied the bottom here by x plus 3? So it's 1 times x plus 3 on the top, which is x plus 3. So now we simply add the tops together. So 1 plus x plus 3 is the same as x plus 4. And that's all going to be over our bottom here. So you can either write it in this way, or you could write it as your x squared minus 9 if you prefer. Okay, either would be fine. So this is an example where we actually need to change both of the bottoms. And also have a good look. Sometimes you get lucky and the bottoms are the same to start with. Right, let's just have a go at a couple more examples so we can see some of the added complexities that sometimes come in here. Okay, so same thing again. Our bottoms are going to be x minus 6 times bracket 2x minus 1. Both of them are going to have the same bottom. That's what we need. Okay, and this is an adding on the top. Okay, so x minus 6 times 2x minus 1. So we've got x bracket 2x minus 1. So that, if we expand it, will give us 2x squared minus x. And then on this side, we've got 2x minus 1. So we're multiplying by the x minus 6. So 4 lots of x minus 6. If we multiply that out, we're going to get 4x minus 24. So if we take that top line and add them together, we've got 2x squared minus x plus 4x minus 24. So altogether here, we've got 2x squared plus 3x minus 24. Okay, so this one might be worth seeing if we can factorize that top so that we could simplify it. I'm just going to give it a quick go. So it would be double brackets, and it would be 2x and x. Now we've got a lot of combinations here, but 24 and 1 is unlikely because they're too far apart, and so is 12 and 2. It could be 8 and 3, or it could be 6 and 4, either one of those. I'm going to try the 6 and 4 combination first of all. So we've got 2x and x, so we're trying to make 3, aren't we? So it's more likely to be 4 and 6 than the other way around. So 4 2s are 8x, 6x is 6x, but they're not going to make 3 for me. Let's try it the other way around just in case. So 6 2s are 12x, and 4x, no, so that is definitely not going to work. So let's try the 8 and the 3. So again, I'm going to try the 3 and the 8 this way round. So 3 2s are 6x, and 8 times x is 8x. I'll try it the other way round. It may be that this doesn't factorise. They don't always. So 8 2s are 16x, and that's 3x. That's not going to make 3 either. And I don't believe that the other possibilities would. So in this case, I've given it a bit of a go, but this isn't going to factorise. Okay, so our answer is just 2x squared plus 3x minus 24 all over x minus 6 in brackets multiplied by 2x minus 1 in brackets. Okay, so let's just have a look at one more of those just straightforward adding ones, and then we're going to look at how it happens with equations and what to do there. Okay, so our new bottoms, x plus 2, x plus 3, same for both sides. Adding these, so we multiply this by this, so we multiply the top by this. Now we've got a more complex top, so we're going to have double brackets to expand on top here. And then on this side, we need to multiply by the x plus 2. So let's take this first of all. So we've got x times x, that's x squared, x times 3, that's plus 3x, minus x, minus 3. And if we tidy that up, we'll get x squared plus 2x minus 3. Okay, so for this other one, we've got x squared plus 2x plus 7x plus 14. If we tidy that up, we get x squared plus 9x plus 14. So now what we just need to do is add all of this to all of this. So we've got 2x squared, we've got 11x, and we've got 11 on the end there. Okay, so all of that is going to be over our x plus 2, x plus 3. I'm not going to try and factorise that top. I'm pretty certain it won't, because 11 is one of those awkward numbers. So I'm going to move on to showing you what to do when you encounter one of these but in an equation. So here we go. So you see the only difference now is we've got an equals part here. So what we're going to do to start with is ignore that. So we're just going to do the adding as normal. So we're going to have x times 10 minus x as our bottoms. I'm going to add the tops. So we multiplied by 10 minus x, so we want 4 lots of that. So 4, 10 minus x. I'll expand that down below in a minute this time. I really haven't left myself enough room. Okay, and on this one, we just need to multiply by the x. So that one is just straightforwardly 3x. Okay, so expanding this out and sorting that out, we've got 40 minus 4x plus 3x from the other side. So altogether, we've got 40 minus x on top. So now let's write that down. Got 40 minus x, excuse me, over x brackets 10 minus x. And now we're going to bring down that equals bit again. So this equals 2. So in order to be able to solve this, what we need to do now is get rid of this and start working towards having a normal looking equation. So to remove a bottom, which is dividing the top, we need to multiply by what's on the bottom. So if I multiply this side by all of this, that will cancel and go away. So on this side we'll have 40 minus x, and on this side we will have 2 times all of that. So we'll have 2x 10 minus x. So now we need to start expanding and getting everything together. So let's start with this side. So we've got 2x times 10, so that's 20x. And 2x times minus x, so that's minus 2x squared. and on this side we've still got the 40 minus x. Now I'm going to move everything so it's over on this side, because I can see I've got a quadratic equation here, okay, and I don't really want minus x squared terms. So we're going to add 2x to both sides, and we're going to take away 20x. So that means we're going to have 2x squared. Actually, I'll do it a bit shorter. So we'll have 2x squared plus 40 minus x equals 20x. And then if we take 20x away from both sides, we'll have 2x squared. So we'll have minus x minus 20x, so that's minus 21x, plus the 40 equals 0. So now we're in a position to try and factorize and solve this. Okay, so I'm going to jump a little bit with this because I'm running out of room to a certain extent. Or actually, let me get a piece of paper so I can do that instead. Right. So it's going to be 2x and x. So now what we've got to do is we've got to look at the possibilities that we have here. So we've got 40 on the end, so it could be 40 and 1, it could be 20 and 2, it could be 10 and 4, it could be 5 and 8. So it could be any of those. Now just remember that one of these numbers has to be doubled and the other one doesn't because of this. So let's see if we can figure out which version of this it is. So we've got 2x and x. So we've got a reasonably big number. I'm going to try the 5 and the 8 to start with though. Okay, so if we do 5 and 8 this way, so 5 2s are 10, and 8 times x gives me 8x. That's only going to give me 18. Let's try it the other way round. So 8 2s are 16x, and 5x is 5x, and 16 and 5 make 21. So we've hit the jackpot here. Okay, now we want minus, so both of those have to be minus. They also both need to be minus, otherwise they wouldn't make plus 40. Okay, so that means to carry this on now, we've got 2x and x. Now make sure we get them in the right bracket. So we want the 2x to be multiplied by the minus 8, so that's going over here, and the minus 5 therefore goes here. So this equals 0. So to get our first solution, we do 2x minus 5 equals 0. So 2x equals 5. So x equals half of 5, 2.5. And then finally, simple one, x minus 8 equals 0. So x equals 8 is our other solution there. So I'm just going to give it a go at doing this with one more example of an equation. And I'm going to go and grab a piece of paper right now because I suspect I'm going to need an extra room. So here it is. Okay, so I'm going to do this one because you can see it's got that added little touch here of having a fraction on this side. So I'm going to show you how that one works as well. So we ignore this and we focus on this. So we're going to have x plus 4, x plus 4. That's our bottoms for both of these, and it's added on the top. So we did x times this to get the bottom, so we do x times x, so that gives us x squared for this one. On this one, we multiplied by x plus 4. 1 times x plus 4 is x plus 4. So we add our tops. We've now got x squared plus x plus 4 all over x plus 4. and that equals the 3/4. And we're going to do something similar to what we've just done. So we don't want any bottoms. So let's deal with this one first. So we've got 3 divided by 4. So if we multiply both sides by 4, that will cancel and we'll be back to the situation we had before. Now just be careful, that 4 is going to multiply everything here. Okay, so that means we're going to have 4x squared plus 4x plus 16 on the top there. And then here our bottom hasn't changed, but that equals 3. Whoops. So now we're going to get rid of this one by multiplying by all of this. I haven't really got room to write it in like I did with the 4, but if we multiply this side by this, it will cancel that. And if we multiply this side by that, we're going to end up with 4x squared plus 4x plus 16 here, and 3 lots of this. So we're going to have 3x brackets x plus 4. So let's expand here. So that's going to give us 3x squared plus 12x. And then what we're going to do is get everything onto one side. So we're going to take away the 3x squared and the 12x squared so that we have 0 left on this side. So 4x squared minus 3x squared is going to give us x squared. 4x minus 12x is going to give us minus 8x. And then we've got our plus 16. So our last step again here is to factorise. It's a bit of a simpler one this time because there's no number in front. So numbers that make 16, 16 and 1, 8 and 2, 4 and 4. But the only ones that make 8 when they're added are the 4 and 4. Because we want minus 8, it has to be minus 4 and minus 4. And just double check, minus 4 times minus 4 does make plus 16. So in this particular example, because both brackets are the same, there is actually only one answer. There's only one value of x, because we've got x minus 4 equals 0. There's no point doing that twice. And that leads us to having x equals 4. So that's how we add, subtract, and solve equations with algebraic fractions.